Hi, this is Adrian from Live to Learn Academy, and welcome back to our new lesson. We are on chapter 4, so we are going to be going through lesson 4.1, solving polynomial inequalities. For those of you guys who aren't subscribed to the channel, I know a lot of you guys are watching this, but you're not subscribed. Please subscribe to the channel. It really helps our channel grow and helps us reach the audience of all you students in Ontario. Now, if you are somebody who's interested in tutoring, feel free to click the link in our description. It'll take you to our website. Our team would love to get in touch with you. But without further ado, let's get straight into the lesson. And by the way, guys, likes, comments, subscribing, it all helps the channel. So help a brother out and let's get into it. Okay, chapter 4, we're going to be talking about polynomial inequalities, okay? A lot of my students in the past have always messed up these questions, and I want you guys to really understand that these questions are free marks, okay? They're free marks if you truly understand the process of how to solve these questions. So a polynomial inequality, okay? How it's kind of going to look like is it may look like this, okay? So let's say I'm going to give you a polynomial. So we all know what a polynomial is. A polynomial is this. So we have the polynomial. And the inequality is this, right? Now the inequality is always going to say greater than or less than 0, or greater than or equal to or less than or equal to 0. So for this particular question, it's greater than 0. Now the process is where you need to get down, okay? The process is, first step, you got to factor the polynomial. Okay, now there's many ways to factor these polynomials. Most of these polynomials are going to be cubic functions or fourth degree functions, mostly cubic functions. So when you factor the polynomial, you may have to use different methods. You may have to use factor theorem plus synthetic division, which is the most common way of doing it. In some cases, it may be sum or difference of cubes, like the last lesson. Sum or difference of cubes. And in some cases, it can also be factor by grouping. Okay? Now, sum and difference of cubes, factor by grouping, factor theorem plus synthetic division, all of these things are just to factor the polynomial so you get it into 3 factors. Okay? That's all you're doing. Now, the second thing it's going to ask you to do in the process, the second thing you want to do once you factor it is you have to determine the roots. Okay, so we're going to determine the roots. Now, what are the roots? The roots are the same thing as saying the x-intercepts. So for example, if you had a polynomial and the polynomial looked like x minus 1, x plus 2, and x minus 3 after you factor it, then we know we can get the roots x equals 1, x equals negative 2, x equals 3. Okay? So step 1, factor the polynomial. Step 2, determine the roots. Step 3, plot the roots on a number line. Okay? We're going to plot the roots on a number line. And the number line is going to go from negative infinity to positive infinity. So let's, using the example we went through just now, let's say we have negative infinity, we have positive infinity, and we're going to plot the roots. So negative 2, 1, and 3. Okay? So we plot the roots on a number line from negative infinity to positive infinity. Step 4, what we're going to do is we're going to take this number line, and we're also going to look at the equation we have. Now, mind you guys, I'm going to go through this in real depth, but I'm just trying to give you an outline of how to solve these questions so it makes sense with the process, and then we'll get straight into a question, okay? So remember, this is greater than or equal to 0. Okay, so we're going to look at each zone for step 4. You're going to look at each zone. This is one zone, this is another zone, this is another zone, this is another zone. And we're going to take a number from these zones, and we're going to plug it in to here to see if we get a positive or negative. Okay, so I'll show you how what I mean by that, but I'll show you in the example. But here we're going to say we're going to plot point, we're going to plug points from zones into the factored equation to determine if it is positive or negative. Okay? So we're going to plug those zones in. And then step 5, we're going to look at our polynomial equation. And we're going to identify right away, if this is greater than 0, we're going to identify, is this equation asking us for positive or negative? If it's greater than 0, it's going to be asking us for where is it positive? Okay, where is it positive? Now, mind you, if it was less than 0, if the question said less than 0, it's going to be asking us where is it negative? Okay, so this is the process. Okay, and then what we're going to do from this process is we're going to actually create the zones where it is positive or negative, and that's going to be your answer. Okay, now some of you guys may be looking at this and you might be confused on step 4 or 5, maybe even step 3, 2, 1, who knows. Let's go through a question, guys, to really see how to do this. Okay, and one thing I want to mention also is when you're doing a factor theorem, this section of factor theorem, you're going to do a guess and check. And I'm going to show you guys how to do this, okay? So let's go through an equation, the equation that I stated above here. Let's try this as an example question. So we're going to follow this process to do this example. Very, very easy way of doing it. I'm going to show you guys. Okay. So the first thing, I notice it's a cubic function. So what I'm going to do first is I need to factor this cubic function. And the way I'm going to factor it is I'm going to guess and check a number into and plug it in as x and see if it equals 0. If I guess and check the right number and it equals 0, using pretty much what I'm doing is I'm using factor theorem, then I can clearly identify that that is indeed a factor. So step 1, I'm going to have to factor this, but we're going to factor using synthetic division, so I need to guess and check. Okay, so when I'm guessing and checking, there are 5 key numbers that I want you guys to know when you're guessing and checking. And 99% of the questions that you're going to get when it comes to this type of problem, it's going to be one of these 5 numbers. Okay? So you can guess these 5 numbers in whatever order you want. I would say if you're rushing on a test, you want to go in a good order because, just to save time. So I would say first start off here, then here, and then go to the negatives afterwards when you're guessing and check. Now, mind you, this is just the order of how I want you guys to guess and check, which will make your life a lot easier. So let's say I plug in 1 into this equation. So let's say I say P at 1 is equal to 4 times 1 cubed minus 12 times, P at negative 1. Negative 1, negative 1, minus negative 1 plus 3. If I plug these in, I'll actually get negative 4 minus 12 plus 1 plus 3. So if I plug this in, right, what I end up getting is negative 4 minus 12, which is negative 16, plus 1 is negative 15, plus another 3 is negative 12. As you can see, when I plug in negative 1, I get negative 12. What does that tell us? Therefore, x plus 1 is not a factor. So this is me just guessing and checking just to see if this is a factor. Mind you, the only way this is going to be a factor is if it equals 0, right? Because I have to get p at the number has to equal 0 for it to be a factor, right? This is what factor theorem is. And we're trying to test out guess and check to find the factor. Let's say I plug in another number. Let's say I plug in p at 3. Then I'll get 4 times 3 cubed minus 12 times 3 squared minus 3 plus 3. If I do this, what will I get? I'll get 3 cubed, which is 27, times 4. So 27 times 4 gives us 108, minus 9 times 12, which is 108, minus 3 plus 3, so we get 0. Now, this is one of those cases where I actually got 3 to get me 0. Now, obviously, I didn't put 3 here, right? But it is a value that you can test. Most times on a test, though, guys, you're not going to get 3. You're going to get any one of these numbers, -2, -1, 0, 1, 2. So we get p at 3 is equal to 0, which basically confirms that, therefore, this is a factor. Now, guys, the whole point of identifying if it's a factor or not is only so it can help us do the synthetic division. That's why we need to identify if it's a factor. Because now that we know it is a factor, we're going to go straight into our synthetic division to find the other two factors, or the quadratic in this case. So if p at 3 is a factor, it'll be x minus 3. So what we'll do is we'll do synthetic division with the factor that we just found and the original equation. So we're going to get 4, -12, -1, and 3. And we're going to do out the synthetic division. So we're going to do out the synthetic division. So 4, 3 times 4 is 12, -12 plus 12 is 0, 3 times 0 is 0, -1, -3, 0. So we know that 0 is the remainder. And then over here, it's going to be 4x squared plus 0x minus 1, which in turn just becomes 4x squared minus 1. So what does that tell us? We did this whole guess and check to find the first factor. And then we did the factor that we found, which was 3, and we divided it by the whole polynomial to get the remaining quadratic. What that tells us is that now we know that p at x is going to be x minus 3 for that first factor, and then 4x squared minus 1. And then if we factor this a little more, the quadratic, we'll get 2x minus 1 and 2x plus 1, because we factored this guy over here. So all of this, guys, is pretty standard. All we did right now is we used factor theorem to find the factor, use synthetic division to find the other two factors, and then now we pretty much simplified this whole thing in factored form greater than 0. So this is all for the first step, guys. Step 1, that's all we did. Step 1, boom. Okay, so now let's go to step 2. Step 2 is we actually got to find the roots associated with the factors. So what are the roots in this case? It's going to be 3 from this guy. It's going to be 1 over 2 from this guy. And it's going to be -1 over 2 from this guy. So we got our roots. Okay, step 3, let's plot it on a number line. So we have -infinity to infinity. I'll actually... Yep, -infinity to infinity. Okay, we got -1/2, +1/2, and then 3. Okay, so we plotted it on the number line. Now step 4, what are we going to do? We're going to take this number line, and we're going to compare the number line to our original equation, p at x. So we're going to compare it to this original equation. And this is where we're going to do the zone analysis. Okay? So the zone analysis is between here, 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 and here. So we got 4 zones here. So in this zone analysis, I'm going to pick a number between -infinity and -1/2. So let's say I pick the number -10, for example. It could be any number. It could be -5. It could be -100, right? I chose -10, okay? What I'm going to do is I'm going to take this -10 and I'm going to plug it in as x. Okay, so I'm going to plug in -10 into each of these, and I'm going to determine if this is positive or negative. So if you look at this, if I plug it into the first one, I'm going to get a negative term. If I plug it into the second one, I'll get a negative term. If I plug it into the third one, I'll get a negative term. So I'll get 3 negatives for each of these 3 factors if I'm plugging -10. Okay, then what I'm going to do is I'm going to go to the second zone. So what's a number between -1/2 and 1/2? I would say take the easiest number, which is 0, and then I plug the 0 in to each of these 3 factors again. So we're trying to plug it into the factors to get to find out if it's negative or positive. So I plug in 0, I get negative, and I get positive. Okay? And we're going to repeat this pattern for this guy and this guy. So between a half and 3, I'll take the number 1 and I'll plug it in to the 3 factors again. Okay, I plug in 1, I get a negative 1, I also get another positive. So I get a negative, I get a positive, and I get a positive. And then for the last one, I'll take I'll take like an outrageous number. I'll take like 100, for example. Plug it back in, I'll get positive, positive, positive. Okay, so the reason I'm getting the negative and positive is because we have to find the overall zone. We want to find out if the overall zone is positive or negative. So if I have a negative times a negative times a negative, that means the overall zone is going to be 2 negatives make a positive times a negative. The overall zone is going to be negative. Overall. Okay, everything in blue is overall. If I do the same thing with this guy, well, you got positive and positive, which would mean the overall zone is going to be positive. With this guy and this guy, positive and negative, the overall zone is going to be negative. And then this one, the overall zone is going to be positive. Okay, cool. So that's step 4. This is what I mean. This is called zone analysis. Okay. Okay. Zone analysis. So before I go to the 5th step, guys, I just want to make sure you guys are following here. The first step, we're guessing and checking to find that factor using factor theorem so that we can determine if it's a factor or not. The faster we are at guessing and checking, the better we can, go straight into the synthetic division to find the quadratic and then get our factored form. So if we're slow in this part, this is where a lot of people waste time. It's when it comes to factoring these things. That's why I gave you guys a little rule of thumb. Always try these 5 points. They usually end up working out for this textbook and the questions in this course. So on a test, I want you to start with these 3 first and then go to these 2. Now, that being said, people who, in this specific question, 3 happen to be the factor, right? So this is a one-off, but you guys get the point. Then you go into synthetic division, get the whole thing in factored form, find the roots, put the roots in the table. Sorry, not the table, the number line. And then once you get the number line, you do the zone analysis. Okay, cool. Now the question here is asking, what is the question asking? It's saying, where is p at x? So if p at x is equal to x minus 3, 2x minus 1, 2x plus 1, greater than 0, the question is asking, is this positive or negative? It's asking, where is this thing positive? Where is it positive? So this is where we got to look at our overall zones to determine, in this zone it's positive and in this zone it's positive. So what are those zones? Those zones are negative a half to a half and 3 to infinity. Those are the zones. Boom and boom. So this is why it's important to understand what the question's asking, because if the question said less than 0, then it would be the other 2 zones. It would be from negative infinity to negative a half and a half to 3. But because it asks for the positive, we have to actually determine where it is on that sense. Now this symbol, guys, is called a union. Okay, this is what it's called, a union, but all it basically means, this basically means and. So you can think of it as just meaning and, like this zone and this zone. Okay? So this is the premise of these types of questions. Now, a side note, right? A side note. Anytime you have greater than or less than signs, all of your brackets are going to be soft brackets. Okay? Anytime you have greater than or equal to, less than or equal to, all your brackets are going to be hard brackets. Anytime you have a negative infinity or a positive infinity, it's always going to be soft brackets around negative infinity and positive infinity, because we don't actually know what that number is because it's infinity. It's like infinite, right? So that's why it's always going to be soft brackets. But if we ever had a greater than or equal to sign, that means it's definitive. It means that that is what it is. So it's going to be a hard bracket. So there you have it, guys. I hope this lesson, really, shaped a lot of your understanding when it comes to these things. The steps you want to follow, first you got to factor the polynomial. I would say 90% of the time you're going to get factor theorem and a synthetic division, so make sure your guessing and checking is on point. Then determine the roots, put it on a number line, plug the roots into the zones to do the zone analysis, and then double check with the question. Is this asking for where is this positive or where is this negative? And you know that by looking at the greater than or equal to sign or the less than or equal to sign to determine that. So if this video helped you understand this concept, guys, if you like the channel and really support us, this channel will grow. Feel free to share this video to any of your friends who are taking the class with you. If you're someone who needs tutoring and you want to go dive deeper into the course and you may be struggling and need help, feel free to click the link in our description. Follow us on Instagram. Our team would love to get in touch with you to help you ace this course. But without further ado, I'll see you guys in the next video.